Hello and welcome to C# 102 Week 7. I'm going to be here, and so will Jason Busby.
Hello.
And Gavin Whitlock.
Hello.
Hey. Okay, so today is we're going to be wrapping up the course. This is the last class for this course. And we're going to be talking about some some really interesting stuff that's going to lead into some of the major focuses that we're going to have in the next C# course. We're going to be talking about collections, for each loops, IEnumerable, Iterator blocks, and we're going to wrap up the day with some basic definitions of some design terms that I feel that at this point people who've been working in their code base should have already identified these concepts, but we're actually going to talk about the actual real terms to describe these concepts. So with that, let's go ahead and start with a basic review over for each loops and collections. We have been talking about for each loops, but we're actually going to be diving into how a for each loop is implemented, why it works the way it does, and what sort of fun stuff you can use with the for each loop. This is going to lead into one of the major focuses of 103, when we're really going to be talking about some of the awesome functionality that was exposed in C# 3 that have paved the way to some of the most interesting bits of syntax that I've seen out of any statically typed language. Don't everybody talk at once. Hello?
Yes.
Oh, I was just making sure people are still here.
I thought the students were important, not us.
Well, yeah, but... Okay, so let's talk about collections real fast. What's a collection? Well, a collection is a class that's going to allow us to store data in certain ways, and depending on what type of collection we use, we get additional...
Nelson, I thought all classes were basically things that allowed us to store data in particular ways.
True, but collections are a little bit more specialized in that they're tailored to store 0 to many items.
Thank you.
And each one of the collection classes has different bits of functionality. We've talked about lists, for example, like a list of int. We've also talked about initialization syntax as well, which we can use with collections. We've talked about dictionaries. Both of these are collections. In addition, we've also talked about arrays. Now, as far as whether or not an array is a collection is really up in the air. The fact is, arrays are typically considered to be a piece of the language itself, allowing us to express the concept of arrays. But as we know in .NET, arrays do have a sort of runtime representation, the system.array type, which gives us a variety of members on this object. But I typically do not refer to arrays as collections. And I think one of the reasons I don't is because of the connotation of an array, like I said previously, is sort of something that's built into the language specification itself. And in many other languages, arrays do not get treated as normal objects, whereas collections typically do. So the great thing about these three concepts, a list, dictionary, and array, is that the C# language exposes to us a bit of syntax that allows us to iterate over each one of the items in each one of these collection types. And that's going to be the for each loop. And as we know, the for each loop works on each one of these collection types. You'll also realize that the for each loops are statically typed, meaning I say var item and list, but the implicit type engine will actually expand this to for each int item and list, because list is of type int. That's where the correlation comes into play. When we loop over more specialized collections, however, we typically get other things back. You'll notice if I hover over this var to show what it would expand as after the implicit typing engine gets done doing what it does, you'll notice it's a struct system collections generic key value pair. And the key value pair of each one of the items in the dictionary is going to be, the key type is going to be typed to whatever the key is typed to, and the value is going to be typed to whatever the value is typed to. So in the case of item, we now have a an object that is kind of a wrapper around the concept of a key and a value. So again, this is just a review at this point, talking about the for each loops and how they can be used between a variety of objects, which is awesome because the same concept, the same language construct of a for each loop can be applied to lists, dictionaries, hash sets, arrays, and even your own custom types. So at this point, I remember there was confusion about for each loops earlier. I'm sure many people here have gotten, by doing the homework, have gotten experience using them. But really, right now is the time to ask any question you have about a for each loop, because we're going to be moving on and expanding the syntax of a for each loop into what it looks like under the covers of the C# language.
Yeah.
Yeah.
Very long pause there. Didn't know what was going on.
Oh, someone's running a question.
Yes, I'm back.
Did you?
You didn't know I'd gone, did you?
Well, I did note the silence earlier, but I just assumed you were ignoring me.
You didn't notice I was just offline all of a sudden. No, we've got gale force winds.
Oh wow!
The power's flickering at the moment. And it wasn't this time. It wasn't enough to turn my computer off, but it obviously was enough to make my router reboot.
Gotcha.
Or router.
That's better.
Reboot.
Router. That sounds like rooster. Every time you say router,
I'm so Beavis and Butthead every time I say that. But anyway, yeah. So if I disappear again, that would be why.
Okay, so we do have a question pending. And I'm kind of waiting.
I haven't got a question panel anymore either.
Where'd you put your question panel?
I had to reboot the webinar because...
Maybe you should get a better router.
Ashley, she always shows up to make me smile. That's right, cleaning toilets with a router. It's okay, Gavin.
I find it particularly bothersome because it is spelt the same as router.
Okay, if you remove a member from a collection while you're looping through it, the loop stops. Is this something you would solve with link, or would you use an overload or similar? That's a very good question. The fact is that if I were to, for example, in any way alter the underlying collection that I'm looping over, such as saying list.add10, this will not create an infinite loop like it might look like it would at first. At first you'd be like, well, it would just never complete. But the actual answer to this is you'll get a nice exception, a runtime exception, saying collection was modified, enumeration operation may not execute. That is a very nice, I personally very much like this limitation because it prevents us from doing, or it prevents us from trying to shoehorn the concept of iterating over a loop or iterating over a collection into trying to alter a collection. And those are two very distinct operations. And I really do appreciate this. Not only that, it will very, very often, this error will underscore race conditions, where you have multiple threads of execution in your program, one that's enumerating a collection, and the other one that's altering a collection. Now, obviously, you don't want, in the case of multi-threaded coding, you don't want what happens to be undefined. You want to define the behavior of what should happen if you're looping over something at the same time as adding it. So this exception really does throw throws the entire program into a state of an error, and it tells us that we have a problem that we should address in an explicit manner. But if you did want to do this, I will introduce one method. Actually, no, I won't introduce one method. I'll just do this. if you really, really, really wanted to do this, the appropriate way of handling it is to copy the collection as it exists in the beginning of the for each loop, and then using that copy to enumerate over it. So you'll notice that the way this code works now is that it doesn't throw us in an infinite loop, because when we say list.add10, we're adding it to the list that was copied. You'll notice that the list type has a constructor that takes in a very, very specific type called IEnumerable, in this case of int, called collection. This IEnumerable type is pretty much the most important aspect to working with collections, and we're going to be talking about that quite a bit. So you don't, if you want to edit a collection while looping over it, you should always copy the collection out, iterate over the copy, and then modify the original. Okay, so I hope that answered that question, because that's a good question. That's something that does cause a lot of people a lot of misery at first.
Well, the first case you tend to come across it is when you've got a whole load of I don't know, shapes, and you want to remove all the triangles from a list. That's usually you'll go, well, for each shape in a list of shapes, if shapes number of edges equals 3, remove it from the list, and then you'll get that exception saying, well, you can't do this.
Yep. In that case, you would still make a copy, or you would use the list.removeAll, and you would pass in a delegate. But we're, of course, haven't talked about delegates yet. Okay, so
yes, I mean,
but yeah,
my solution was more along the lines of reverse for loops. Although
that is one of the most common. You're right, that is a very common situation that a person will find this exception in. And as of right now, I would recommend creating a copy of the list and removing things out of the original. And then once we talk about delegates, that's going to change a little bit. Okay, I don't get it. How is that a copy? It's a copy because this is a new instantiation of a list. I can expand the syntax a little bit. I can say var list copy equals new list event, passing in list, and then I can iterate over list copy. So this is the exact same code, just expressed in a more
if you show
explicit way.
The parameter tooltip for your new list, that should make it clearer.
Yep.
The overload he's using of list takes in. This is like a copy constructor, really. It
is, but I want to underscore the fact that this isn't like a language-wide feature. It just so happens that list does have a constructor that takes in an IEnumerable. This isn't a feature that's, unlike C++, this isn't a feature that's expressed universally.
Yeah.
Okay. And you'll also find that this constructor is very common between most of the collection types. Even the list of dictionaries. Oh, come on.
Yeah, I think presumably that's just because it is one of those things you generally, if you're working with collections, sooner or later you're going to be wanting to do.
Yeah. Like if you'll notice another overload of dictionary takes in an iDictionary.
Yeah.
And the same thing is true for most of the collection types. Okay, so now let's go ahead and expand our for each loops a little bit and talk about what this code looks like. Now, if you'll recall, something similar happens. Does everybody remember the discussion we had over using? Because using is a very similar construct where, not in the sense of what it does, but in the sense that it really marries or creates a bridge between the C# language specification and what's provided within the BCL. So you're just adding to the copy. No, I'm looping over the copy. I'm adding to the original. The copy is only created for the purposes of iterating over these items. The modification is done to the original. If I had done the modification to the copy that I was looping over, I would get the exact same exception. Because I'm doing the same thing now. Okay. So again, I hope people remember the discussion we had about using. because what I'm about to show is a very similar thing, where the C# language will take this syntax and turn it into something else. We'll turn it into this, basically.
It sounds like Darth Vader typing.
Okay. What we have here on lines between lines 14 and 8 and 19 is exactly what is the shorthand for what the compiler turns into something that looks like lines 21 to lines 37.
Okay.
So if you notice that
What's an enumerator?
if I run this code, you'll notice we get the same result for both of these bits of code. You'll also notice something interesting too. This pattern is this bit of the pattern is a using statement. In fact, I could have written this as a using statement, but I decided to expand it in its entirety instead of using the using construct. So,
what exactly is an enumerator? Because this is something that's sort of conceptually, what is it? Is it each item in turn, or is it something that points to these items, or is it the index of the items in turn, or is it something none of the above?
An enumerator can be implemented in any way that you see fit, but what it actually is, and the definition that will work no matter what the internal implementation of an enumerator is. An IEnumerator is two things. It is a pointer to the current item that it's looking at. And when I say pointer, I don't mean programming pointer. I mean like I'm pointing my finger at the current item that it's looking at. Then it also has a very important piece of functionality called move next. The move next functionality on an enumerator moves the pointer one ahead, and then it returns a Boolean indicating whether or not the enumerator has stopped. This actually has some very important, very, very significant implications. An enumerator doesn't necessarily have to be anything. This is an abstraction. It's an interface. An enumerator may be a computation, like calculate all the primes between 2 and 100. And the move next would check, okay, are we at 100? No, we're not. Calculate the next prime, set my current member to that next prime, and then return true. So the idea of an enumerator is it's just a slice of one thing at a time looking at it. And that it doesn't really represent a collection. It can represent a collection, and it fits very well into the definition of a collection, but it's like a square and rectangle thing again. An enumerator is more appropriately, and this is a term that you will see in lots of programming literature, it's more appropriately what's considered to be a sequence. And a sequence is a sequence is 0 to an infinite amount of values, one after another. So you can conceptualize almost any collection or any procedural computation in terms of a sequence. Calculating the prime numbers is a sequence. It goes on for infinity.
Do they have to be of a type?
Yeah. Well, in .NET they do. Yes. Enumerators are typed. So in this case, you'll notice on line 22, I'm using an enumerator event. So they do have to be homogeneous as far as their type goes. So you can think of a sequence as anything that's 0 to infinity. So you can have, like I said, you can say, loop over give me a sequence that represents every real number. Give me a sequence that represents every even number. Give me a sequence that represents every prime number. Give me a sequence that represents every square of a number. Give me a sequence that represents how many all the game objects in my world. Give me a sequence that represents all the users in my system. And you can use sequences to represent anything, whether it's procedurally generated and whether or not that ends, whether or not it's infinite. So they're a very incredibly powerful construct. And you'll notice that, like I said, collections are sequences, but sequences are not necessarily collections. So the great thing about this abstraction is everybody knows that a list is implemented as a dynamic array. We've talked about this quite a lot. A list.
Everybody who's listening in the past knows that.
A list is implemented in the terms of a dynamic array, and as we know, arrays are contiguous blocks of homogeneous data. And that means that you might think what this code is doing is saying, okay, well, we're pointing at index 1, now we're pointing at index 2, now we're pointing at index 3, and so on and so on. And in fact, that is what happens behind the scenes in this case. But watch when I do this. I've instantiated, instead of a list, I've instantiated a linked list. And it's not going to let me do that because of the way linked lists are implemented. Now, everybody should be, and if you're not familiar, that's okay, but a linked list does not store data in contiguous blocks of memory. It connects data or dynamically allocated data in a very specialized way. But you'll notice that my for each loop doesn't change. My for each loop will still compile. So will my expanded for each loop. Both of these will work the exact same way.
Well, this is kind of ironic because I was just about to mention that it does seem very much like the implementation of a linked list. It's got the IEnumerator, that is, because you've got the object and you've got the way to get to the next one.
Yep, and that's all it is. If you can turn the IEnumerator object into a simple function, if you think in terms of a functional programming, and that function is a function that will either return an item or it will indicate that the sequence has been enumerated over. And you'll notice that because we're implementing these in terms of these magical interfaces, these very, very anemic interfaces, you'll notice they don't have a lot to them. I do want to talk about this in a second. I'll leave that until I'm done with this. But you'll notice that because enumerators and enumerables are implemented in terms of this abstraction, and the for each loop is implemented in terms of this abstraction, expanding the code is the exact same. We can represent almost any computation that we want with this exact code, which is why it's such an awesome construct. How does the enumerator know? Well,
no, carry on, because what I've got to say isn't specific to enumerators.
How does the enumerator know what to move to when you use move next, because of the way the list is constructed? It knows it because it keeps track of it internally. The enumerator is an instantiation of an object. When I invoke list.getEnumerator, I am instantiating a new enumerator that is coupled tightly to this list. And this object at runtime, I don't know if I'm going to go ahead and turn this back into a list implementation. And I don't know if the debugger is going to show me the innards of this. I hope it will, because that'll be a fun little discussion. But let's see. Let's see what the debugger shows me. Yep. So you'll notice this object has in it a reference to a list, the list that's enumerating over, and then the current value, and then the current index. Notice when I move next a few times, the enumerator now is pointing at index 2, the third index within the list.
Mm-hmm.
So the enumerator object itself contains a pointer to what item it's looking at in the list, and then it returns it. But the beautiful thing about this is that because we're wrapping this in an interface, that implementation changes depending on what kind of thing you're looping over. Because, for example, if I was to go back to my linked list implementation, you'll notice that the members within this enumerator object are entirely different. It points to a node, because that's how linked lists are implemented internally. So the implementation of this object will change and be appropriate always for whatever collection you ask to get the enumerator from. And the for each loop doesn't care. So you can only use IEnumerable on performed collections that implement get enumerator.
Preformed.
Preformed. Oh, no. Nope. We'll be discussing ways in which we can write our own types and our own methods that implement IEnumerable. IEnumerable and IEnumerator. Well, actually, we need to back up and talk about that. Now, I think that's a good time to bring that up. What is an IEnumerable? So you'll notice on line 27, I have this IEnumerator. But what's an IEnumerable? Well, an IEnumerable is an interface. You'll notice if I go into the definition of linked list, you'll notice it implements IEnumerable of T. This is one of the interfaces that it implements. If I go to the definition here, you'll notice that the IEnumerable of T simply has one method called IEnumerator.
Oh, hang on a sec, Nelson.
Yeah, I was just going to say I lost Nelson as well. So.
Am I here?
Yeah, I did, but I thought it was just me.
Am I here?
So I didn't know. You're back now, but you went away for about 5-10 seconds.
Okay.
Yeah, so back up just a little bit.
So IEnumerable is an interface that you implement, and if you implement it, it will work with for each loops. And IEnumerable forces you to implement get enumerator that returns an IEnumerator of T. So an IEnumerable is a collection or an object that can be enumerated, and an IEnumerator is a specific object that represents the process of sequentially going through each one of the items within that collection or sequence. I do really want to point something out right now. You will see this a lot. It's very, very sad fact of .NET. The very sad fact of .NET is that .NET did not have generics during version 1. Everything in version 1, all your collection types were untyped. They didn't have types on them. They didn't have, they weren't list of T, they were array list. And this is cruft that's left over by the first version of C# and .NET. It's very disappointing to see, but it's there. What this is right here is the IEnumerable non-generic version.
I was going to say, yeah, people might be confused as to what you're getting at. If you just take a look at the second tab across the top, that's IEnumerable of T.
Yep.
It's actually IEnumerable out T.
Oh, we're not talking about that.
Yeah. Do you want to just make sure everyone's clear on the difference?
Yeah.
What that means?
The difference is that this class, this interface, was implemented on the first version of .NET, and it's not typed. It's not typed in any way. It doesn't constrain or in any way enforce that the items returned by this enumerator are of a particular type, and as a result...
So I could put an int in there, and then a string, and then a fish, and then a giraffe.
Well, yeah, the other way around. You could get back an int or a string or a giraffe from this.
But all from the same... What I'm saying, you can put two different types into the same one.
Yeah, for the corresponding like array list, which is the corresponding non-generic version of a dynamically sized array. So with this non-genericized version, what we have here is an enumerator that can return any data, and if it returns data that you don't expect, you'll get a nice runtime exception. This version, the version implemented as of C#2, is typed. You know it's typed because it has a generic parameter. Again, we haven't really talked about generic parameters, but just take it for granted that the existence of these angle brackets right here turn this into a typed enumerable, meaning that this enumerable can only enumerate over things that are of homogeneous type. They can only enumerate over things that return the same type for every item within the sequence. So this only exists for legacy purposes. And if you see it used, I hope you understand what it is, and that it exists for legacy purposes. It's cruft left over by an old version of .NET, and it shouldn't be used for new code. But you will also notice that linked list, for example, implements both IEnumerable of T and IEnumerable. This is actually a sad requirement, because you'll see here the IEnumerable of T uses interface inheritance to make it force it that you also implement IEnumerable. Meaning if you implement IEnumerable of T, you have to implement two getEnumerator methods. One that returns an untyped enumerator, one that returns a typed enumerator. And we'll talk a little bit more about that later, but the fact is that that will lead to some ugliness. And it's a very disappointing
not avoidable,
fact.
presumably.
What?
You're saying there's no way around that. We're going to have to write both.
Yeah, that's just how it is. Okay, couldn't you just use IEnumerator as all of your collections instead of list for dictionary? That's actually a great question. I'm probably going to be talking more about it later, but I'll give you a quick rundown. The fact is, all of the collections implement IEnumerable. As a result, if I have, let's say I have an inventory class, and I want to, he has a private list of, come on, auto format this, please. Okay, he has a list of product. And let's say you wanted to expose the concept of being able to enumerate over all of the products within the inventory. The way in which you would do so would look like this. Can anybody who isn't segfault explain to me why this, given the knowledge that we've that people have hopefully gained in the last 30 minutes, why this is significantly preferable than to instead have done this?
Because that says it's bad.
Can I explain, with everybody's knowledge of IEnumerables up until this point, explain to me some of the reasons why this is significantly preferable? I'm going to go ahead and add a public void add product method. And I'm going to go ahead and shoot this at the bottom. I'm going to go ahead and use this class. I'm going to say var inventory equals new inventory, inventory.add new product, name equals product 1. Now, some people... Oh, segfault, shut up. See, I will point out, anybody who did read what segfault said and understood it, I don't care that that's a possibility, because at the end of the day, the fact is, if somebody wants to be that facetious with my code, they could always just fire up reflection and dig deep into my fields anyway. So if they're going to abuse my code like that, I'll just let them. But I won't make it easy on them. Anyway, so what I have here is an inventory. And the inventory has a public IEnumerable of products. This is beneficial in so many ways. The first and most important reason why this is good is because if I do inventory, and I'm going to go ahead and nuke my using system.link, And just for a quick teaser about what link is, we've talked about extension methods. We've talked about extension methods being applied to IEnumerables, or not IEnumerables, being applied to interfaces. So there's your little tidbit there. But now if I do Inventory.Products notice anything about this? Just importantly, notice the lack of anything by doing Inventory.Products . There's no add, there's no remove, there's no clear, there's no sort, there's no anything. The only thing, there's one thing that I can do. I can get the enumerator. That's it. Which means that I can use this with for each loops. And because this code expands into, I'm going to go ahead and expand the for each loop. Because this code expands into IEnumerator of product equals Inventory.Products.getEnumerator, try while enumerator, move next, var product equals enumerator dot current, finally enumerator.dispose. Because this code expands into this, we can express anything that we want to, any sequence that we want to return from our classes as IEnumerable of anything. Now, the reason alone of what I just talked about, as far as the enumerables do not expose any addition or removal of items. Can anybody think of another reason why this is a very, very good practice? There's another great reason why this is an incredibly important practice, and it's going to play into a very ridiculously powerful construct of the C# programming language. Well, yeah. That's the first reason. Nobody can change my data except for inventory. Inventory owns products. But there's another really important thing about this abstraction. What do you get when you turn something into an interface? What's the implied benefit of using an interface over a concrete type? Well, abstraction, of course. We get an abstraction, and what we get from an abstraction is the fact that it does not matter where this data came from. This data could be coming from a dictionary, it could be coming from a hash set, it could be coming from a computation, it could be coming from a custom implementation of IEnumerable, it could be coming from a database, a file system, an XML file. It doesn't matter what it's coming from. And because we've abstracted the concept of enumerating over products, we are now free to change the implementation details of inventory to whatever we feel is better suited for it. And the rest of the code's not going to care about it. The rest of the code is just going to be calling the getEnumerator method on it.
Yeah, you see,
You're really low.
Suddenly baffled by what on earth we're talking about now. Ever since you wrote out that sort of the long version of that for loop, I haven't really understood why that's better. All of a sudden you're saying you've got less functionality and that's much better. And I don't understand why.
It's all about the ownership of data and encapsulation. Because the inventory type is specifically a type that's responsible for handling a list of product, regardless of where this is actually stored. This could be stored on a database, this could be stored in the file system, it could be stored from a network stream. It doesn't matter where this is stored. For this implementation, I have decided I want to use a list of product. That's how I want to store the data. But if I had done this, actually I'm just going to change this. Instead of returning IEnumerable of product, it's going to return list of product. Notice how this code still works. But now what I can do is I can reach in and say, well, Inventory.Products.add new product. Let's say name equals product1. And let's imagine for a second that our inventory has an invariant on it that specifies that only products added must have unique names. So what I'm going to do here is I'm going to implement that in the add method. I'm going to say for each var current product in products, if current product.name equals product.name, throw new argument exception, product names must be unique. By allowing me to do this, which will become very tempting and will result in people doing this, makes it so that the concept of our collection, this concept of our storage that inventory encapsulates, is no longer an implementation detail. It's no longer an implementation detail because the public interface of inventory, per definition, is allowing client code direct access to the underlying collection. And as a result, the inventory no longer owns that data, and I'm able to force the class into an invalid state by intentionally violating one of its invariants.
Okay.
Or let's say we are storing this on a database, and so, for example, we still have an in-memory collection of lists, or an in-memory collection of product. But when we delete all of the products, when we clear our inventory, what we need to do is we need to execute a SQL statement, a SQL delete statement. So you might do something like this, public void clear, which would execute the SQL for you. But now a client code could be tempted to do this, and it would look like it works. Because we're not encapsulating that data properly, it looks like this should work, but it's not going to invoke the functionality that we want to force people to invoke. It's very poor design. So if you used a list, it would have to come from a list only, right? But let's say that we wanted to change our implementation of inventory. We don't want to store things in a list anymore. We decided that it's very important that we relate products by their names. So I want to store products as a dictionary now. Oh, hey, look, I've just broken all my code.
Yeah.
By changing the internal implementation of inventory, any client code is no longer going to work properly. Of course, we'll have to change our the actual implementation of inventory to match the change we just made.
Mm-hmm.
But you'll notice that our property is now broken. And anybody who reached in and modified our list, that client code is now broken as well. Because our implementation detail was coupled to the public interface of this type. And when I say public interface, I mean the public members of this type. We lose inherent bits of maintainability because we're not encapsulating our data.
All right.
So when you call IEnumerable.Products get, you gain access to products, but you can't access the list methods of products. Exactly. If this is an IEnumerable, which would become this at this point, products.values, we cannot reach in and modify the underlying collection. We've exposed this property in terms of an abstraction and not of a concrete type. So wouldn't I just make products private? No, because I wanted the ability for people to be able to loop over all the products in my inventory. I wanted to express that bit of functionality. Because the fact is the inventory shouldn't do things like print out products to the user. The inventory should really just be responsible for storing products in memory and potentially persisting them. So we want other components like the UI to be able to loop over all of our products in the inventory, but we don't want to break the encapsulation of our data storage. The way that we store data in inventory is an implementation of inventory. The knowledge of where products come from begins on line 12 and ends on line 31. And you would have to make your own implementations of add remove clear, assuming you wanted that style IEnumerable. You would do so on the inventory type itself. You would have an add method, a clear method, a delete method, a remove method, maybe a remove all products that are out of stock method or something like that. The importance being that you would be able to express in those methods additional functionality. Because I realize that something a person might be confused about here is why I even have an inventory type. Why do I have an inventory? Why don't I just instantiate a dictionary of string and product and name my instantiation of this dictionary inventory? Wouldn't that work as well? But what I'm trying to point out here is that when you do go to want to represent a complex collection of data, for example, you want to be able to code in database interaction, file system interaction, network interaction. You want to be able to code in your invariants. You want to be able to say, express, I only want products that have unique names in my system. This is how you would do so. You would write an inventory class, and you would add that custom logic to it. And then, once you want to expose your collection of products, once you want to allow other people to see what's in your inventory, you should do so by an IEnumerable and not a concrete collection type for a variety of very important reasons. Now, it's important to understand, though, that an IEnumerable product is not a new object. That might be another thing that people might be getting confused about. The IEnumerable is a list, because a list implements IEnumerable. So look at this. How many lists do I have?
I think Segfault may have overestimated slightly.
Yeah.
68.
I have one list here. But the difference is we've been talking about polymorphism since for this entire class because it's one of the most important concepts of OOD. And polymorphism is the idea that you can statically reference the same runtime object, but through different eyes. So when we access the list variable, we're accessing it statically typed to a list, and it gives us all the functionality of a list. When we access this object right here through the eyes of an IEnumerable variable, then we've cut off all of the things that makes a list and cut it down to the bare minimum of what's required to enumerate over that collection using a for each loop. So using IEnumerable.Product allows someone to see the list, but to add a product, they would be forced to add products the way you choose, i.e. using an add product method that you've exposed. Exactly. Because you're giving more control to your inventory and taking it away from the other programmer might mess something because they don't know how your system works. Yep, exactly. Not only that, we'll see an even more powerful thing that you can do with IEnumerables. Thus far, I want to make it clear, even if people are still having a difficult time conceptualizing this, I want to make it clear that thus far, the reasons I've been giving for using IEnumerables as a way to publicly expose collections should be enough to use them. But the stuff you can do with them this class is only going to be the beginning of the stuff you can do with IEnumerables. Okay, so
I think I'm probably with Wolf Knightley on this. Could this maybe be whiteboarded?
Yeah, I can try. I don't know if I can.
Well, I was kind of... It seems to me that, because you've mentioned several times that by implementing IEnumerable, you are enabling for eaches and for loops to work.
Yes.
So are there other interfaces? I couldn't work out what to say then. Are there other interfaces similar to that that relate to other types of language construct?
Yes.
I mean, is there a direct relationship?
IDisposable.
And I was going to say, is there a kind of hierarchy of complexity when it comes to collection types?
How do you mean?
Well, in that you can think of an array as the most basic possible. I mean, in the same way that a while loop is the most basic form of loop, and then you have like if and then for, and is the same applicable to the collection types? They generally add more.
There really isn't much of a hierarchy. Every collection implements IEnumerable, and some collections implement iCollection, some collections implement iList, and some collections implement iDictionary. So there are a variety of interfaces that have to do with collections, and every collection will implement a subset of those available interfaces. But those other interfaces don't provide language-level features. The only other interface that I'm aware of that provides a language-level feature is IDisposable, which allows you to use the using keyword.
Right.
Okay, yeah, I'm going to go ahead and do a quick break and then start to whiteboard stuff out to the best of my abilities. So, pausing the video. And we're back. So let's go ahead and talk about what we've been discussing, but let's make some pictures. Okay, so we have our inventory. In our inventory has a list of product. And the thing about this, the list of product, is that it's an implementation detail. As a result, it really should be encapsulated into inventory. Here's why. The inventory should be completely in charge of how the product stuff is stored, how it's filtered, how it's processed, how it's ordered, what happens when a product is added, what happens when a product is removed, how to perform specific queries against our products. There's a bunch of stuff that we really need to be able to encapsulate within inventory so that it's a properly designed class. The problem is we have other code. Let's say the UI. Now, the UI is going to need to enumerate over all of the products in the inventory to present a listing to the user. So what we do is we do expose the list of product, but we expose it via IEnumerable. And by exposing it through IEnumerable, we don't lock the concept of our products being stored in a list. We don't expose that to anybody else. We hide that information behind an IEnumerable. That allows us to pass anything in. Remember, a dictionary, a list, a linked list, a stack, a heap, a queue. All of these types are IEnumerable.
Are there others? I mean, or have you?
Oh, there's plenty. There's
like priority queue and stuff.
Yeah, there's hundreds.
And array, for that matter.
And array. Yep, there's hundreds of types that implement IEnumerable. But because all of these types implement IEnumerable, we can pass any one of these into a property that is of type IEnumerable. Anyone. I can pass a dictionary, a list, a linked list, a stack, a heap, a queue. I can pass a computation. I can pass a special object that I create by my own design. And they can all be represented by this one abstraction. This one
and of course, as we
abstraction.
talked about in the interfaces section, that of course acts as a filter. Only things that are on the IEnumerable. Everything else is then not there anymore. It's treated as being an IEnumerable at that point.
When you statically type an object, and remember the difference between statically typed and the type of an object at runtime. Remember, if we do var L equals new list of int, and then we do IEnumerable, of int e equals I, or L, sorry, that's an L, we only have one object here. The new operator instantiates an object in dynamic memory. And then when we assign this guy to this reference, this object in memory also gets assigned into E. So E and L both point to the same dynamically instantiated bit of memory. The difference is their compile time type. Because C# is a statically typed language, every variable has a type at compile time. That type determines what methods you can invoke on the object. So IEnumerable of int E here acts as a filter, a facade, over the object itself. Because the object itself is a list, but it's also an IEnumerable. When we say var L equals new list, what we get is a reference to the list component of the object. So we get a reference to this bit. This is what gets returned by the new keyword. When we implicitly convert an object typed from list of int into IEnumerable event, we get the same object, but we only get the members that are part of IEnumerable. We don't get the members that are part of list. The great thing about that is this box can now be anything. This could be a dictionary, or a stack, or a queue, or a heap, or a computation, or database access.
A completely random but vivid example. Humans and cows both implement the IMammal interface, but only cows implement the iQuadruped interface.
Yeah.
Humans implement the iBiped interface. So if anything has to do with having 4 legs, only the cow gets it.
Yep, because you won't be able to use the functionality of a quadruped on a mammal, because the mammal only shows the members.
Well, whales are mammals
shared.
as well. You know, and a whale is another mammal, and that has a completely different set of, that has a breathing and, Anyway, you get my point.
I can't stress this whole IEnumerable thing enough. The only times that you will see me publicly exposing lists are when I'm representing DTOs, data transfer objects, where the DTOs themselves don't enforce invariance on them, and they are by definition what they store. Therefore, it's okay to expose that implementation detail because they are by definition an implementation detail. And you'll also see me publicly exposing lists when working interop with other libraries such as in Hibernate. But typically I will never expose a list or a dictionary or anything else.
So in terms of situations when you would, would a better way to be would a way to think of those as being when what you're essentially dealing with, whatever your type that you've made is essentially a list with extra features, if you like, as opposed to something.
Well, yeah, it's a list with potentially other bits of data. For example, I might have a person DTO that has a list of addresses. The person DTO is in itself defined by the state it carries with it. Therefore, the state itself is conceptually what it is, and therefore it's not appropriate to abstract the state of itself to anything else. But that one of the most important aspects of a DTO is that it doesn't enforce invariance, and it doesn't have any functionality on it. All it has is it's just a bag of properties. So that's a situation where I'll find myself publicly exposing a collection, but that situation is very few and far between.
Yeah.
Okay, so jumping back to code, hopefully people are starting to understand the relationship between collections, enumerables, and then the relationship between enumerables and enumerators. How's everybody feeling so far? Okay, what I'm going to do is going to be fairly intense. I'm going to implement my own IEnumerable.
Hurrah! What, without ReSharper?
Yeah, sadly. Alright, let me get my tablet out of the way. I wish the wireless module wasn't horribly broken. Okay, so let's go ahead and implement an IEnumerable. I'm going to implement a sequence of even numbers.
Do you want to start with a clean, empty thing
Fine.
that has nothing confusing else there to clutter up things? You could just delete what you've got there rather than opening another. And I dare anybody to ask about IEquatable. I mean, surely you're going to have to deal with that, aren't you?
No. I'm just going to have to do IEnumerable of int, implement the members, and then IEnumerator of int, implement the members.
I'm assuming you're going to walk through this once it's typed out. No, NATO, you're supposed to ask Nelson, not me. You've got to tell him it's vital to your understanding of what's going on that he write it out. For something that's got 28 parameters. Without ReSharper, as they call it, yeah.
Okay, so I've just created an implementation of IEnumerable and IEnumerator. All I've done is I've created two classes, one nested class and one parent class. The parent class is called EvenNumbers, and the nested class is called EvenNumbers Enumerator. The EvenNumbers Enumerator implements IEnumerator event, and the EvenNumbers class implements IEnumerable event. The members that I'm forced to implement because of IEnumerable event are these two. Remember, the first one exists just because of the fact that the early versions of C#, or the first version of C# and .NET did not support generics. So this is the non-generic version of it that we're forced to implement. However, a common pattern when doing this is to simply return the result of the strongly typed version, which has the exact same effect. So you'll notice that truly the only member I had to implement was what you have there on line 44, getEnumerator, that returns an IEnumerator of type int, and I'm returning an instantiation of the EvenNumbers Enumerator, and I provide the count. Now, count is going to be how you limit how many even numbers get returned, because even numbers is very much a sequence.
Yes, there are an infinite number of even numbers.
So we want to constrain how many even numbers we return. So how's everybody feeling with the implementation of IEnumerable? We created a class, we implemented IEnumerable, then the only member that we truly had to implement was an IEnumerator, getEnumerator, in which case we return an instantiation of our custom enumerator type.
So assuming that was all you'd done, what functionality, if any, would you currently have out of it? Or would it be broken because you hadn't actually implemented?
Well, you'll notice my moveNext method just returns true. So basically, if I put this in a for each loop right now, it'll just spin forever.
Right.
I'm sure I could remove the system collections with the using, but I really do not want to import system.collections. System.collections is the namespace that contains all the untyped .NET collection types. So I really don't want to bother with that.
Have you actually, as part of the C# courses, talked about namespace cluttering?
Yeah, I think so.
Obviously, I think we only... It feels to me like we only did during the C++ one, because obviously it's more...
No,
I know we talked about it
I'm
there,
pretty sure we've talked about namespaces in depth.
But in terms of just cluttering them up by bringing stuff...
Yeah, we haven't really... You typically want to keep your usings as tight as possible, because the whole point of namespaces is to delineate bits of functionality. And if you don't... If you import a bunch of stuff in, you increase the chance of running into a collision.
That's cool. I was just double checking.
Okay, when you implement the IEnumerable, what return type did getEnumerator come with? The return type of getEnumerator is always going to be IEnumerator of whatever type I implemented the IEnumerable for. So because I implemented IEnumerable of T, I implemented this interface, I must provide an implementation for the method called getEnumerator that returns an IEnumerator of int. And this is a facet of generics.
5 minutes on generics?
That would take longer than 5 minutes.
Pleading.
The fact is,
yeah.
All I want people to understand is the correlation between this int generic type parameter and this int generic type parameter, because they must be the same.
Yes, I mean, if you were to change one of them to a string, the other one would have to be as a string as well.
Enumerator is the object that's currently being looked at in the collection. Yeah, and the enumerator is the pointer in the sequence. You can instantiate as many enumerators as you want for any given enumerable. The enumerable is simply an object that provides an enumerator.
When you say when you say you can instantiate, say you had an IEnumerable of strings, would you then perhaps have an IEnumerator of strings that would give you them in alphabetical order, and then a different one that would give you them in order of length?
That's an incredibly good question. The low-level implementation, I wouldn't provide any of that functionality in. Then what I would do is I would create additional implementations of IEnumerable that decorated another IEnumerable. So this will always just return even numbers, but if we wanted to, for example, return even numbers squared, we would create a square enumerable, and the square enumerable's constructor would take in a reference to another enumerable that it wraps around. And then the enumerator that you get back from the getEnumerator method will decorate that functionality for you. We'll get into that a little bit more once we start talking about yield.
Right.
Do you get a protection level compile error for this class? No. Build succeeded. I don't get a protection error because I'm not returning an even numbers enumerator. I'm returning an IEnumerator. IEnumerator is a public interface, even if this is a private class.
Actually, yeah, somebody said yay, no, I'm sounding confused. I don't think you answered quite what I intended to ask. How's that for chivalry?
Well, no, we'll talk. I think.
But, what I was saying is, essentially, would you, if you wanted to be able to enumerate the same list, you want the same type back, not like an int or the square of an int, but you still want just to get back the same type of thing out of the list, but in two different ways.
Yeah, exactly.
Can you give me an example?
This is actually something we're going to go over in depth. Okay. I guarantee you. And if what I think you're asking isn't right, then just bring it up again. But I'm almost completely certain that when we get to another point, it'll make a lot more sense. Why doesn't getEnumerator non-generic have an access modifier? It doesn't have an access modifier because this is explicit interface implementation. The reason that this is explicitly implemented is because it would be a compiler error to implicitly implement this member, because it would conflict with the member that's defined on line 44. So it has to be explicitly implemented. Do the other collections define a nested enumerator class in this way? I'm not sure. most likely. Okay, so now let's look at our enumerator. This is the meat of our type. We have a variety of members. First of all, we have this private int count. This is a custom member that we're using for our own purposes to limit how many even numbers we return. So that's not a part of the implementation. It's an implementation detail of what we want to create. And you'll also notice that the constructor simply takes in account and sets it to its field. The two important members, or two of the important members, are current and then the other current. Again, there's two currents. The first current relates to the generic version of IEnumerator. Notice how there's a correlation between this integer parameter and this integer property return type. However, you'll also notice that we have another member of current that returns an object. That is cruft left over from the IEnumerator non-generic version. And you also will notice that it's explicitly implemented, because if it was implicitly implemented, it would conflict with the other current member.
Essentially the same thing was happening just now, but with different names.
Yeah.
Current instead of...
yeah, instead of get enumerator. It's very annoying. I hate it. Okay, then we have these methods. We have a dispose method because IEnumerators implement IDisposable. The for each loop will always invoke the dispose method, just like a using construct will always invoke the dispose method at the end of an enumerator. Typically, the dispose method will be blank. We have a public void reset method. This method I will typically never implement. I'll just leave it throwing a not implemented exception. And the reason is that I never access enumerators directly. I always use them in for each loops, and for each loops do not invoke the reset method. Then we have the most important method, the move next method. This method is invoked every iteration of the for each loop. And then we return a Boolean indicating if there are any more items to loop over. So let's go ahead and implement this. Actually, honestly, we probably don't even need that, because that's handled by the fact that we have line 15 for us.
Yeah, and your naming was getting a bit squirrely as well.
So now we have the amount of numbers that we've generated, and then the even number that we return. So by assigning current to something will result in the for each loop presenting us this number. And we want this to start at 0. So I'm going to go ahead and say I'm going to go ahead and say current equals -2. And the reason is move next is invoked on the first iteration of a for each loop. So we want to start a little bit behind so that when move next is invoked, we add 2 to the current, and then we get the first number being 0. So now let's go ahead and use this.
You're probably going to hate me for asking this. Could you have not done return number of numbers plus plus is less than count?
I probably could.
I was just wondering. It goes back to question 12 again, but...
So here are the first 100 even numbers. NATO, in a good way? Okay, does everybody understand what this example is supposed to do? The fact is we're getting the first 100 even numbers.
Why are we not getting 198?
198. Because of the way it's implemented.
Can you do it with 10 numbers instead, please, instead of 100?
1, 2, 3,
Right,
4.
5.
Oh, we have an off by one error.
You see?
1, 2, 3, 4, 5. There we go.
Yeah, that's better. Thank you.
Okay, so what we have here is an implementation of IEnumerable, and we're able to throw our custom class into a for each loop. So the biggest thing, the most important thing is going to be the move next method. The move next method is responsible for two things. It's responsible for getting the next value in the sequence, and it's also responsible for deciding if the sequence is over yet, which is why we have 2 bits of functionality in this method. We calculate the next even number simply by adding 2 to our current, and then we indicate to the caller whether or not the sequence is done with. How's everybody feeling about that, at least? The move next method is invoked on every iteration of the for each loop. Okay, I'm going to go ahead and write up some code. Okay, yeah, I'll go ahead and do that then actually first. This for each loop expands to this. When would I ever do this in production code? Funny story, I wouldn't. I'm going to be covering a bit of syntactic sugar very shortly here that allows us to express enumerators very much easier. But understanding what enumerators look like is incredibly important. But I am going to describe some very important syntactic sugar very shortly. You would only do this if you're using custom sequence of data and not a collection as you showed before. Typically, I would do this mainly when I'm. The biggest reason I would do this is to perform operations on an existing collection of data. If I wanted to annotate a collection by saying that I want the squares of all the numbers in this collection, or I want to filter out these items out of this collection, at that point I would use this concept, although I would express it in a more concise manner than I have, because as you see, true enumerable and enumerator implementations are very verbose. So that's why the developers of the C# language gave us a very convenient way of doing it. Okay, are there any more questions about this? I mean, I know this might be a huge shock to everybody's system, but I do really, I do want to go on a break really shortly here, but before I leave, I really want people to see a way that we can express what we've just expressed in a significantly more concise manner. Okay.
Dun, dun, dun.
What I've just done is I have done exactly what I did before, in the form of creating two classes, but I've done it in a method instead.
I'll tell you what, could you block comment out all the code that's replaced?
Well, yeah, I can't because then the program won't compile anymore. But this entire thing is replaced by these few lines. This will result in the C# compiler behind the scenes generating essentially what I've defined between lines 8 and 59.
Does that start at 0? Sorry, I didn't notice when you actually played it.
No, it doesn't.
I mean, in terms of output.
Now it does. Oh, wait a sec, I'm stupid. Now it does. That should start at 0. Yep. This has the C# compiler generate an enumerable for us. Okay, I'm going to go ahead and pause the video and go on a quick break, and then we're going to break down the yield construct and talk about how amazing it is. But I hope people understand why having the context of a manual implementation helps understanding how a yield works. And we're back. So what I left you guys with was this. This is an interesting, a very unique feature of the C#.
And there he goes again.
Hello?
Ah, good.
Am I here?
I mean, not good, but it's...
Yeah, you disappeared for a few minutes.
Am I still back? Am I here? Can you hear me?
You're
Well,
still
I hope
back.
so. We're talking to you.
Okay, well, I'm just making sure. Okay, so a very unique C# language feature called an Iterator block. And Iterator block is categorized by a method that returns an IEnumerable of something, and it has at least one yield return in it. Those three things combined define an Iterator block. An Iterator block gets transformed by the C# compiler into a class. The class that it gets transformed into is a class that implements both IEnumerable and IEnumerator, and it represents the computation that we provided here in C#. It represents that in the form of a state machine, meaning that the C# compiler, this is a bit of genius coding on part of the C# development team. They turn this imperative language that we have here, this for loop and this yield return, they transform it into an entirely new method that somehow manages to do exactly what we've expressed. It's a very well-tested, very, very stable, very well-established bit of logic here, but it will always transform this method into the corresponding implementation of IEnumerator. It's an incredibly powerful, incredibly ridiculously complicated, but it does so much for you behind the scenes.
Specifically with for loops?
No. You can use anything within a yield. Well, not anything.
Can you use a for each loop?
Yeah. You can use a for each loop, a while loop. You can use if statements, switches. There's some funkiness with exception handling, obviously, because.
So, sorry, I'm just trying to pin down the actual syntax that is the kind of the sign for it. It's literally the yield return in. Is there any? I suppose there's no reason. Is there a reason to do that when outside of a loop situation at all?
If you wanted to, I could do this, for example. I could say yield return 0, yield return 2, yield return 4, and I can delineate this by saying console write line waiting ... console read key. What the C# compiler does, and like I said, this is an amazing bit of technology. the C# breaks this entire method out into a state machine. So watch this. When I hit F5, notice it says 0, waiting. The 0 indicates to us that line 87 executed. Line 87 executed after line 64. When and I can underscore that fact. I can say got number blah. Got number 0, waiting. I hit a key. Got number 2, waiting. So it executed line 87 and then returned into this method and executed a bit of more logic. And so you can see here that this is indeed a state machine, that whenever it hits a yield return, it yields the execution back into the for each loop and only resumes the execution of the method until the for each invokes the move next method again. Ridiculously, amazingly powerful magic. The C# compiler, like I says, wow, words are hard. The C# compiler, like I said, takes this method and chops it up. It just chops it up. This method isn't, if I decompiled what happens to this method, it wouldn't even look recognizable because of the amount of magic that it's inserted between each yield return statement. But what it does is it creates a state machine that will, every time it hits yield return, it yields execution back into the for each loop. And then when the for each loop iterates again, execution returns to this method, and so on and so on. This method eventually gets, so this method in particular directly results in a move next that looks like this. The amount of magic that's going on behind the scenes is astounding. But that's how it works.
And as Nato said, okay.
Understanding the translation between an iterator block and the class that is generated by the C# compiler isn't something that you're going to ever be able to fully grasp. I mean, I can't say that because, maybe you do go into the specification, maybe you do decompile Roslyn. Roslyn is the C# compiler implementation written in C#, so it's going to be entirely possible to decompile it and actually look at the implementation. Or you can check out Mono, because Mono has a corresponding implementation and it's open source. It's not important, though, the magic that goes on behind the scenes that translates this bit of imperative logic into a state machine. What's important to realize, what I want everybody to realize, and if you don't understand this, then please let me know and ask questions. But what I want people to understand is that when we have an iterator block, again, an iterator block is categorized as a method that returns an IEnumerable of something and that has at least one yield return. If I didn't have a yield return right here, and I tried to build, I would get a compiler error. Because it's saying, get even numbers, not old code paths, return a value. Because it doesn't. Right now, this is just a normal method. And this normal method, I've said, must return an IEnumerable event, but I don't return an IEnumerable event, therefore it can't compile. But by the existence of a yield return, it does compile, because it gets translated into an iterator block. And an iterator block becomes an implementation of IEnumerable and IEnumerator in such a way that it can be used in for each loops. Very close to Twilight Sparkle level magic.
It seems to me a lot like yield return acts a lot like turning down a page in a book, turning down the corner of a page in a book.
Yeah.
You start off reading the book from chapter 1 and you read a bit, and then it's dinner time, so you yield return. So you put a bookmark in, and when you come back to it the next time through, you pick up where you left off. Is that?
Yeah. It's exactly what it does. It goes away and gives execution back to the for each loop. and then comes back when the for each loop asks it to. And like I said, the transformation is magic, but the resulting code makes sense. It takes this code and turns it into a switch statement, saying, if we're on state 1, then do this. If we're on state 2, then do this. It's probably
I just got a nostalgia hit from...
It's probably closer to Little Pip's aptitude for telekinesis, in the sense that while not necessarily diverse...
Dear Lord.
While not necessarily diverse, it is an instance of immense, ridiculous algorithm development that I applaud the C# developers of implementing.
I like what Sequel said, like a choose-your-own-adventure book, you hold the page you are at last in case you die.
So,
Cheat.
So when does the for each return execution back to the yield? Great question. Let's debug it. I'm going to delete all this code right here. And I'm going to leave us with the expanded form of a for each loop. Remember, what we have right here is the expanded form of a for each loop. Instead of saying var enumerator equals even numbers.get enumerator, I'm going to say var enumerator equals get even numbers 10.get enumerator. Remember, the get even numbers method is the iterator block that returns an IEnumerable event. So let's debug this and see how the execution works. So I'm going to hit F11. Now I'm going to hit F11 again. You'll notice something amazing by me hitting F11. We invoked the get even numbers method. We did. That method has been invoked. It's been called. Then I hit F11, which supposedly is supposed to
Should have
jump.
stepped into it.
Yeah, it's supposed to jump into whatever method I invoked.
And there's Nelson taking another break. He'll be right back after these technical difficulties.
Am I broken again? Hello?
Yeah.
Am I here?
Well, that's a big break.
Pony.
We've got static.
Bunny.
Bunny.
Okay, there you go.
Okay.
All
So I'm
right,
back.
and there he's back. All right.
Okay, so you'll notice something amazing. When I was on line 74, I hit F11, which supposedly, it's supposed to jump into the execution of a method that I invoked. But nothing happened. I just jumped down to line 76. What happened? Well, what happened is the get even...
I was going to say it should have gone to... Lag.
Yeah.
It should have gone to line 64.
Exactly.
You'd expect it to.
Yeah, by hitting F11, you would assume that line 64 would become executed. The get even numbers method still exists, but it does not contain anything that is right there. This code gets placed into a class definition, and the get even numbers method is turned into a method that returns a new object. That is compiler generated, which means when I hit F11, I don't, the way the debugger works in .NET or in Visual Studio by default, it's not going to jump into compiler generated code. Get even numbers is purely compiler generated. Now if I hover over Enumerator, let's look at this. What is this? Enumerator. Console application 1.program.get even numbers. This is a class that I didn't write. The C# compiler wrote this class for me. Okay, so let's continue on our for each loop. Remember, this is a for each loop. When I hit F11 again, we jump to line 77. If I hit F11 one more time, what's going to happen? If I hit the keyboard shortcut F11, where...
I'm not being suckered into answering that.
What line will be highlighted?
This is like QI. I would look silly if I answer that, so I'm not going to.
When I invoke the Enumerator.getMoveNext method, I jump into the first state of my state machine. Execution resumes on line 64. So then execution continues just like normal. This is just normal C# code. I hit F11 again, we enter our for loop, blah, 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 blah. And now we're sitting at a yield return. What line will be highlighted when I hit F11 now? And Segfault... No spoilers, please. Okay, well, we got 179, and that's exactly what's going to happen. The yield return, well, 77, but whatever. The yield return jumps back into. It does two things, two very important things. First of all, it sets whatever we yield returned as the current. As you see, the current is now 0. Our yield return set the current property. Not only that, it returned us into the for each loop. Remember, this is a for each loop. This is what a for each loop looks like behind the scenes. So now that we jump back into this, we now are finally within our user-defined code. The user-defined code I delineated in a way that would indicate that this is what appears within a for each loop block. And number...
So this will actually stay the same, this bit?
Yeah. This bit is the only bit that's going to be the same between the expanded and collapsed version of a for each loop. So now our number is 0. So I hit F11, we jump back to the while loop. What's going to happen? When I hit F11, notice how we didn't jump to the beginning of the for loop, we jumped to the end of the for loop. That's an important distinction. We immediately resumed this method. We paused this method temporarily, and then we resumed it right when we left off, which is immediately after the yield return current plus equals 2.
So if on line 68 there was like a console.write line,
exactly,
we'd be beyond that now.
Yep, exactly. This is not threading. Now, that's the funny thing. I could see where you would take that from. I can see the correlation. But what happens is the C# compiler actually tears apart this method. Okay, and so this pattern continues. Every time we hit a yield return, we jump back into the for each loop. Every time we invoke move next, we jump back into the method. Until what's I at right now? I's at 8. Blah 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 blah. Okay, so this should be it. Yep. Okay, we've now continuously switched between our getEvenNumbers method and our move next. We're now at the end of the method. The end of the method will force the move next method to return false, which, as you'll see, will terminate the while loop. And the for each loop ends. Yeah, I am actually I'm going to do that right now.
What?
I'm going to go ahead and write an iterator block, and I'm going to show you guys what it looks like when it's actually compiled by the C# compiler.
Ooh. Dun dun dun.
Once my...
While his Visual Studio is opening, did you see that ultra cool YouTube video of somebody's made GUR?
Yeah. That was great.
That really was. You just reminded me of it going dun dun dun. Dun dun dun.
Wow. That was a very long time. Actually, someone just said something awesome in BuzzNet. It seems like the more advanced subjects have less and less code to write. Exactly. The more advanced concepts you learn about C#, what you're inevitably going to find is that the advanced concepts of C# are explicitly developed in a way that results in less code being produced by the developer. The C# compiler...
Well, I've told you about my analysis of your coding style, haven't you? It's to write fewer lines of code to do more quicker.
Yeah.
In more CS files. That's a key point. You've got to have as many CS files as you possibly can.
Well, as many as are necessary.
No. That's never. Oh no. That's never come across. As many as you can physically fit into your computer.
By the way, I love the fact that I can get read key by just typing in RK in all caps. The camel casing support of the ReSharper IntelliSense makes me happy. Anyway.
You don't even have to have all caps.
Oh, I guess you don't.
Nope. And you should write true in there.
It doesn't matter. The point is everybody sees that I've brought over the code from my VM into my host. There's nothing different about this code. And if there is a difference, it's superficial. So what I'm going to go ahead and do is I'm going to hit Control-Shift-B, right? So console application 157, remember that? I'm going to go ahead and fire up ILSpy. If I can find out what monitor that decided to... Oh, there it is. One thing I very much dislike about Ultramon is it doesn't... Like, you notice how I clicked on this, and then the icon went away like it's not running? When something's on a different monitor, it doesn't also show that window running on your main taskbar. Irritates me.
Yeah, but you know what's a lot less irritating? The fact that it doesn't crash constantly.
Display Fusion doesn't crash if you don't change your resolution often. That's the one...
And since that's something that has to be done often, you crash often.
True, but I'm just pointing out that's a great piece of software.
I thought that was just down to Nelson failing.
No, it was a piece of software he was running that was causing it to crash often.
What console
he
application
installed
was
it, so he's
157, 157, 157, 157.
Good job this is in C++ class, or you'd be looking to try and find one called...
That's because it doesn't auto-append to...
Fast. Anyway.
Oh no.
Oh yes.
Oh no. ILSpy is too smart.
Maybe?
No, ILSpy is too smart. Let me try an older version of ILSpy.
My Little Spy?
Yes, My Little Spy. Nope.
Nelson would pay money for that.
The old version still doesn't... Oh, this is a sick joke.
What about...
Let's try Reflector.
What about ReSharper's... What about ReSharper's ILSpy application?
That's .peak, I believe. I think I do actually have an I do have an installation of that on my computer.
Of course you do.
Well, I'm trying to run it right now and it's failing.
I can't help that your computer sucks so bad.
Reflector?
No, my trial of Reflector expired, and I'm not going to buy it because the fact that they made it cost money is an insult.
Ouch!
You know, that's what happened.
Everybody should work for free.
No. Reflector was the only free open. No, it wasn't open source, but it was a free .NET decompiler. The second it costed money, let me see. Telerik released a free version of a Reflector clone. ILSpy free and open source. .peak free not open source.
Sweet. So how well did that ILSpy you just opened up a second ago do to serve us?
Well, it did too well, is the problem.
Oh, yeah, that's right. It did so well, we actually had to just close it down and try something else then.
We know what you're trying to show us. So.
It's still... Come on, guys.
How dare it actually fundamentally know what it should be doing?
Come on. This is sad. This used to work.
Hey, Nelson.
Hey, Jason.
You get what you pay for.
But I'm trying to get it to do something dumb.
Mm-hmm.
Okay, I have one more thing I can try. Sadly, this will have to be an IL if it does work. Ooh, there's an ILSpy version 2. Maybe that has an option for... No, it's even better. There we go. And maybe if I switch back to C#. Come on. I really wanted to show you guys this. Basically, what I'm trying to show everybody is that, don't worry, roll Flute and IL. What I'm really trying to show people is what the C# compiler actually generates for us. You'll notice that when I switch over to, I'm working with a .NET disassembler right now. It's a program that takes a compiled .NET program and tries to represent what it thinks the corresponding C#, VB, or IL code should be for this particular assembly. You'll notice that when I swap over to IL mode, that a new class appears. There's some very important attributes of this class. The most important is that the fact it is surrounded by angle brackets is not a mistake. The classes that the C# compiler generates for us are called unspeakable classes.
Yes, they come straight from the Harry Potter world.
It's true. They're called unspeakable classes because they use angle brackets, which are valid for class names in IL, but not valid for class names in C#. Meaning there's...
Can we have frightfully uncouth structs as well?
You what?
Can we have frightfully uncouth classes as well?
No. Anyway, so... yeah, this is an unspeakable class that was generated by the C# compiler for us called getEvenNumbers. The most important aspect is moveNext, and sadly, this is all in IL. And when I switch to C#, it is smart enough to be able to break the yield for me, or show me the yield corresponding code. I know that's the problem. Like it's very intelligent, and it knows that at the end of the day, what I'm really doing is an iterator block. But that means I won't be able to show you guys the code inside of moveNext in terms of C#. Instead, what we have here is the IL. And I don't expect people to understand IL, but some things that you might want to notice really quickly are this. It's referencing a variable called state. It's a field local to this class called state. Then you'll also notice that it enters a switch statement. So it's a state machine. And every time that this moveNext method is invoked, the state machine is incremented and pushed further beyond where it previously was. Then when it enters the switch statement, it only executes the code that corresponds to that bit that's between the yield return. Yield was introduced in C#2, I believe.
Is IL full of go-tos then?
Yes.
Is it entirely built on go-to?
It has to be. At the end of the day, that's all a CPU understands is a go-to.
Cool.
Okay, are there any... Well, yeah, like Segfault said, more specifically a jump statement. Are there any questions about this code? Any more questions? How are people feeling about the yield statement? You don't have to understand what the transformation is. You just need to understand that the transformation exists.
Well, you have to understand the upshot of it. You have to understand how to use it and what to expect it to do.
Okay.
Rather than exactly how it goes about coding out how to do it.
Let's do something fun.
Uh-oh.
We're getting pretty close to the end of the yield statement. Oh, someone just... Is that Malcolm Reynolds? Anyway. Okay. Sure. I was actually just about to pull this up. Could you give us an example of a situation where you would use a yield? Well, let's look at a very straightforward example.
Multi-core processor threading. Your idea of a simple example, like multi-core processor threading.
No, I promise this will be example, or this will be Let's run a method called filter out odd numbers. The great thing about this method is it's going to accept an IEnumerable event called source. It's going to say for each var item in source, if item, oh great, what should I do? Filter out odd numbers. So is even is going to be if item modulus 2 equals 0, then yield return item. How's everybody feeling about this method? It's an iterator.
So by filter out, you mean discard?
What?
What you're aiming to get the even numbers back again, yes?
Yes. Filter out odd numbers. Or how about return get even numbers? The get even numbers function accepts an IEnumerable event called source. It loops over source, and for every even number it finds, it yield returns that item. Meaning we can do this now. Var numbers equals new list of int 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And now we can say var even numbers equals get even numbers, passing in numbers. And then we can say for each var number in even numbers, console write line number, console read key.
So what is the type of the var on line 24?
The type of the var on line 24 is IEnumerable event.
Right.
This is a list event. This is an IEnumerable event. And of course, this is an int.
Yeah.
This is a situation in which I would use yield return block or iterator blocks, where you're converting, and this is hopefully the answer to the question you had earlier, Gavin, where we use an iterator block to decorate an IEnumerable. So the source IEnumerable could come from anywhere. It could be anything. It could be a dictionary, a list, a hash set, a database invocation. But now we've represented this computation called get even numbers that performs an additional operation on it. It filters out things that are not desirable.
Right.
Segfault, of course, but that's not the point. That's for 103. How are people understanding this code? We've been building up this entire class, this entire lesson has been building up to this moment, basically, of using the concepts of IEnumerables, of for each loops, of filtering, of proper abstraction to create methods that work on abstract sequences and return abstract sequences. How would you expand that to, say, extract all factors of 3? Well, I could say if item modulus 3 equals 0. In that case, it's no longer get even numbers, it's get factors of 3.
Well, not factors, multiples.
Multiples, sorry. But you would just change the computation you did in this if statement. Okay, well, I'll introduce another method, another iterator block, an IEnumerable event called square numbers.
Just call it FizzBuzz.
I mean, we could. We could do it.
He was doing FizzBuzz, essentially. Well, perhaps you should get people to do FizzBuzz using this. You haven't made them do any work today.
No, you haven't. It's a little disappointing, actually.
Yeah, that's actually, yeah, well, I'll make people do that immediately before the next break. But how would you expand that to, say, extract all factors of 3? I meant keeping the get even numbers in place. Would you have to make a new block? Yes, what you would do is you would create another iterator block. So in this case, I've represented another computation called square numbers that takes in an IEnumerable event, loops over everything in the IEnumerable event, and yields a square of each one of those numbers. So now I can say even numbers equals square numbers. Notice the ridiculous beauty of this. The fact is that square numbers takes an IEnumerable event. An IEnumerable event could be a list, or it could be the result of another iterator block. Which means I can invoke square numbers and pass in the invocation of get even numbers, and pass in numbers as the ultimate final collection that's actually being worked on. So as you'll notice, I get the square of every even number now, because I've composited that functionality together by using iterator blocks. Does that answer your question, Chris?
And of course, if you wanted to get the even square numbers, you'd simply reverse. Presumably, you'd just do get even numbers, passing in square numbers,
yep,
passing in numbers.
Okay. So, as an exercise to everybody, go ahead and hit participate if you're super stoked on writing some code. Is yield letting you use the return type of the method to return different values? Not sure I understand the question. Yield is letting me yield control or yield execution back into the for each loop on every iteration. Now, the type that you yield, this is another important thing, the type that you yield must be the same type as whatever the return type's generic parameter was. So the generic parameter of this return type is int. So that means that anything I yield return must be in an int, must evaluate an int, or an int expression.
Which makes sense. Yeah, that does make sense, because you are, it's a return statement. This is why I brought up the idea of a bookmark or turning the page down in the book, because you're essentially returning a value and then saying, but next time you come back, it's going to hop in here and carry on from where it is.
Yep.
As opposed to starting over again. If that was just a method that found out whether it was an even number or not, you'd have to call the method multiple times. I think I don't want to confuse you with more over description.
I can try to whiteboard yield.
Well, I mean, Jason, have you got a different viewpoint on how to describe what the yield return is doing at all?
No, I think actually Nelson's done a good job of it. The problem is there's not been any hands-on with the simple stuff, and we've been building up, and hands-on's kind of important.
Okay, so I'm going to put up a nice little prompt for people who want to have practice using this.
See, look at that. Rolling Stone's telling on you, man. Didn't do any hands-on last week. Hands-on, I mean, when I teach, it's got to be hands-on. Critical.
Iterator block?
Yes. This is an iterator block.
No, that is an iterator block. But anyway, carry on.
String.
Anyone for English 101?
Well, Kevin, do you happen to have any classes before 101? You know, like pre-English?
But Nelson level.
No, for me, but thanks for thinking of
Oh,
Nelson,
right.
too.
I wouldn't. How could I possibly have thought of you in there? You're my boss.
I'm always looking to better my
That would be insane.
non-existent English skills.
There's only one thing that you've ever done that always used to bug the living daylights out of me.
What's that?
Well, but ironically, Nelson did it earlier. It was in the middle of a complicated explanation, so I followed up on it.
Yeah, what's that?
Oh, no, it wasn't a mount. That was Logan that caused that confusion. But it was very unique.
Oh, yeah.
It drives me nutty. Things are either unique or not. It's a binary situation. You can't be very unique. Be unique.
Well,
Anyway.
Well, it depends on what universe you're in. There are parallel universes where things can be so much more unique.
Well, in this shed, they're not.
Okay, I do want to point out, though, that I have filled out a prompt, and I would really like people to go ahead and implement this. There's a funny story about this programming problem that I'll explain later, but it's called FizzBuzz. Write an iterator block that returns an IEnumerable string and accepts an int count of how many items to return. For every third iteration of that particular iterator block, return fizz. For every fifth iteration, return buzz. For every 15th iteration, which is every iteration that's both a multiple of 3 and multiple of 5, return FizzBuzz. For anything that doesn't return a specific string, return the current number of the iteration that you're on.
Okay, Wolf Knightley just fell out of his chair.
You should be seeing
Something like this.
1, 2, fizz, 4, buzz, fizz, 7, 8. Ah, this is hard to do off the top of my head.
I've got
fizz,
your back. I've got your back,
buzz,
Wolf.
11, fizz, 13, 14, FizzBuzz, hurrah,
1,
and
2,
so forth.
fizz, 4, buzz. So that's 6, that's fizz. Yeah, I'm just going to do this.
Hilarious.
Just do that.
It's hilarious to hand this out as the assignment, and you guys are sitting there struggling to figure out what the heck the outcome's going to be.
Well, that's the great thing about programming. You write programs.
I know that.
The
I know
program
that.
does it for you.
It's just funny because right now both NATO and Wolf Knightley are like, where do I even start? Actually,
It's not so much him as...
Anyway, so I'm going to go ahead and pause the video. Okay, so I did get a snippet of code, and the person asked me what's wrong with this. And immediately what I see here is that the number of 15 is being slightly disrespected. It's coming in...
Don't diss 15.
It's coming in as the final else if. But the problem is that 15, any number that's a multiple of 15 is a multiple of 3, and it's a multiple of 5. Meaning that any number that is a multiple of 15 is going to trigger the first if statement instead of waiting until the end.
You've always got to do, if you're doing if, else, you've always got to go from most to least specific.
Yep.
15 is the most specific of these.
Otherwise, the first few if statements are going to be invoked as opposed to the one that you intended it to be. Okay. If you're still working on this, go ahead and hit 1 minute. Otherwise, I'm going to throw the solution up on my monitor. Okay, so let's see how this would be implemented. The first requirement was that it was an iterator block that returned an IEnumerable of string. So we're going to do static IEnumerable of string. We're going to call this FizzBuzz. That's going to take an int count. It's going to say for var I equals 0, I smaller than count I++. then it's going to say if, actually there's a few ways you can do this. I'm going to say var mol3 equals I modulus 3 equals 0, and then mol 5 equals I modulus 5 equals 0. Then I'm going to say if mol 3 and mol 5, then yield return FizzBuzz. Else if mol 5 yield return, what did I say? This was buzz, I believe. Yep, buzz. Yeah. Else if mol 3 yield return fizz. Else yield return I.toString.
And where I was talking about most to least specific before, obviously the order of the two else-if blocks, 54 and 55 and 56 and 57, doesn't matter. They are, if you like, siblings in the hierarchy.
Yeah, because they're not mutually, they're not ever going to trip each other up.
On each other.
Exactly.
Yeah.
But lines 52 is, because you want to trigger that one first. You want to test for that first. Okay, and then to write out a program that actually runs this code, we would simply do for each var number in FizzBuzz. I don't think I specified a driver program, so I'm just going to say give me the first 50 FizzBuzzes, and then console write line number. I'm actually going to start with 1.
And then you'll need to do less than equal to then in that case. Dear me, sir.
Okay. So 1, 2 fizz, 4 buzz, 5 fizz, 7, 8 fizz, buzz, 11 fizz, 13, 14 fizz buzz.
Indeed.
Yep. Okay, I'm going to we're just about done with Iterator blocks, but I'm going to step things up a little bit.
Bum, bum, bum.
Does everybody see what I just did?
I do, but I'm not going to say anything about it before I find out what you're about to say.
I turned this IEnumerable to be returning an infinite loop, meaning that when I hit F5, it's going to continuously not work because I forgot to increment my index. But now if I hit F5, it's going to continuously go up and up and up and up forever. It's never going to terminate. Which you might be thinking, well, that looks kind of useless. No, it's really not. Infinite sequences are very useful. But when we want to display them, we need to have a way to constrain them. I'm going to write a method called static IEnumerable of string called skip. Then I'm going to write another static IEnumerable of string called take. Skip is going to say blah 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 using var enumerator equals source.get enumerator for var I equals 0, I smaller than count, and enumerator.move next I++, and then I'm going to say for each var while enumerator move next yield return enumerator dot current. So what skip does is it grabs a source enumerable and then it skips X amount of items, or if the source sequence terminates, then it stops the skipping process. But after it's skipped a specified amount of items, it'll then start returning the original items out of the enumerator. So it skips X items and then starts returning the rest of the sequence. Take does something similar. Take is going to be for var I equals 0, I smaller than count, I plus plus. Actually, I'm going to have to do this. Enumerator equals source dot get enumerator. Actually, I can implement this in terms of a for each loop. That might be less confusing. Var index equals 0. For each var item in source, if index plus plus is greater than count, break. Otherwise, yield return item. So take sort of does the opposite. You give it a source enumerable, and it'll return X items from it, and then discontinue. So with combining skip and take, we can make use of infinite sequences. So instead of saying, I'm going to go ahead and do var numbers equals take, skip, FizzBuzz. I'm going to skip the first 5 items, and then I'm going to take the next 100 items. So in this way, I have created an enumerable that wraps 3 iterator blocks and combines them together. The first thing I do is I say, take 100 items. What am I taking from? I'm taking from the skip operation. The skip operation will skip 5 items into the sequence for the source enumerable, which is FizzBuzz. So we're compositing these 3 iterator blocks together in order to get the FizzBuzz results between the 5th item, which is fizz, of course, and we're grabbing 100 of them. Or I can maybe make this smaller and say grab 5. So we get 1, 2, 3, 4, 5, 6 items, which isn't quite correct because I have an off by 1 error on line 84. So 1, 2, 3, 4, 5 items. So we've skipped the first 5 items, which actually I have another off by 1 error because that should be count.
Well, I did wonder. But...
plus 1. There we go. So we have...
No, minus 1.
Minus 1.
But still.
So we've skipped the first 5 items, and now we're grabbing the last... Let's just do 10, because then we'll get a FizzBuzz. No, we need to do 15 to get a FizzBuzz. But anyway, the point isn't the specific off by 1 errors that may or may not still be present within my code. The point is... Oh yeah, it starts at 6, and buzz is 6 because buzz is a multiple of...
No, it currently starts at 5. That is because we're 0-based indices, so it skips the first 5, which are 0 to 4. Well, it's showing me 5, 6, 7, 8, 9, 10.
It's showing 5. Well, no, actually, I think I was right the first time. Because if I skip the first 5 items, that means items 1, 2, 3, 4, and 5 are skipped. I should start on 6, which is going to be a fizz.
Okay.
So this is the behavior that I want. I've skipped the first 5 items, and then I take 15 items.
Okay.
But the important thing to realize is this is an infinite sequence. But I've used other iterator blocks to actually make proper use of the infinite sequence. All right, how is everybody feeling about this?
Essentially, rather than having the conditional inside the while, you've moved it outside of the process. The condition that actually stops the infinite loop from being problematic like it usually is.
Yeah.
Is because you've just moved that condition outside of it.
We did get a question about my for loop right here. This for loop is actually an empty loop. You'll notice that's an empty loop because I terminate the block. I say for var I equals 0, I is smaller than count, and enumerator.move next. This is the important bit. Not only will it check to see if we have iterated this loop count many times, it will in addition move the enumerator forward by 1, because that's what we want to do. We want to take the enumerator and we want to say, okay, I don't want this value, I don't want this value, I don't want this value. By saying I is smaller than count and enumerator.move next, then silence. Hello?
Hey?
Did anybody hear what I said?
Yep. Yep.
So now what I'm saying,
That must have been local.
I is smaller than count and enumerator.move next, I'm checking 2 conditions. First, and I'm doing 2 conditions and performing 1 operation. I'm making sure that we don't skip too many items, and I'm making sure that we don't reach the end of the sequence, and I actually move the sequence forward, count many times. So never call FizzBuzz on its own. Yeah, you won't, well, you could, but you would have to wrap this in code that terminates the for each loop.
Essentially, yes. Don't just, you wouldn't.
Yeah, you wouldn't put this directly in a for each loop, no. But you would be able to annotate it with additional method invocations to limit how far the infinite sequence is going to go forward. Does move next return anything? Yes, it does. Move next returns a Boolean. The Boolean indicates whether or not the sequence has been finished yet. So if move next returns true, that means there are more items that need to be enumerated over. If move next returns false, that means that the enumeration is done.
And presumably it returns false when it tries to move from the last item onto one that doesn't exist. Mm-hmm. Or does it return false?
Yeah, it returns false if it tries to move forward, but it can't. It doesn't return false if it can't move forward on the next iteration.
Right.
In this case, move next will always be true. Yes, because FizzBuzz is an infinite sequence. How is false greater than I?
No. I is greater than count, and
yep.
Enumerator.move next.
These are.
I is greater than count returns a bool, and so does Enumerator.move next.
And they're combined through the AND logical operator.
Do you want to put brackets around them?
Both of these things are just expressions, Boolean expressions that are combined by the AND operator.
I was aiming for parenthesize, but I had a bit of a tongue failure.
Okay, so how are people feeling about this? This does jump up the complexity significantly. It does. I realize that, but I really wanted to show people how advanced and how succinct you can make your code by using these sort of tools. To make this a little bit more straightforward, I can break out each one of these method invocations into their own variables.
Before, I was going to say, it's when you're looking at things like this, you always work from the inside outwards, NATO, in terms of working through what's going on. So they're on line, whatever it is now, 97 at the moment. You know, FizzBuzz is the innermost thing. That is providing the
first value.
Kind of way. And then you work your way outwards.
Yep. So what I have here is var FizzBuzz equals FizzBuzz, skipped FizzBuzz equals skip FizzBuzz 5, taken FizzBuzz, or I could say taken skipped.
Now, at this point, is this going to be broken?
Should be.
I was somewhat confused because wow, I've just completely confused myself. It's just saying var FizzBuzz equals FizzBuzz. So I look at FizzBuzz the method FizzBuzz, which has
An
infinite loop in it. So why doesn't it break?
Yep, that's because these methods do not actually invoke the methods until they get placed into a for each loop. What's the difference between I modulus 3 and I modulus 5 versus I modulus 3 and I modulus 5? The difference is that in the first case you're using the logical AND operator, in the second case you're using the bitwise AND operator.
Essentially, they're two different operators that happen to look similar.
Wait, doesn't yield just wait until a for each loop before it's called or something to run the code? Yes. The yield in iterator block, which is, again, is characterized by a yield statement, is not going to immediately execute when you invoke the method. Instead, it's only going to invoke the bits in the iterator block until you reach a for each loop. Okay, so we're just about wrapping up with iterator blocks at this point.
Cool.
Which is pretty much the end of the class. There were 3 terms I wanted to define for people. They should be terms that people might not immediately recognize, but the concepts of them should be something that people have already been sort of identifying within their own code. So do iterator blocks on with the for each and no other kinds of loops? Yeah, iterator blocks return IEnumerables, and IEnumerables only work with for each loops. IEnumerables do not work with any other type of loop.
Sorry, they only work with for each, not for.
Yeah, IEnumerables. Well, remember, IEnumerables are just objects. Like you see right here, I'm getting Enumerator directly from the source and manually invoking its moveNext method and manually finding its current. I'm doing essentially, I took the anatomy of a for each loop and I kind of splayed it in front of my in my method so that I could change the behavior of it slightly. But the fact is that the only language construct that understands IEnumerables is going to be a for each loop.
Okay.
The only
I'd always kind of viewed for and for each as being sort of looking at the same thing in 2 different ways.
No, the for loop only works with things. I mean, yeah, again, you can use an enumerator inside of a for loop, but that's just going to be invoking methods on an object. The for each loop is the only construct that's actually going to invoke those methods for you magically.
Okay.
The only other part of the language specification that actually involves IEnumerables is initializer syntax. To support initializer syntax, you have to have a method called add on your class, and you have to implement IEnumerable. So if you don't use for each, then you're required to call moveNext to make it work. Exactly. A for each loop, all that is syntactic sugar around the concept of an enumerator. Okay, so how is waiting for the for each to run the code in that yield helping us? It's not my question. Now that I get a little bit more, how is it's not about helping or not helping. It's just what it is. The great things about IEnumerables, we've already covered some of the very important aspects of IEnumerables. The fact is, IEnumerables, by exposing things like a product inventory in terms of an IEnumerable, we get a lot of benefits. We get greater levels of encapsulation, we get a lot of more flexibility, and we prevent users from accessing the underlying collection without doing a lot of work. The iterator blocks are an example of a language feature that work exclusively with IEnumerable objects, and they provide us a lot of great functionality so that we can express modifying, or not modifying, but decorating or filtering a collection in imperative style C# code, and then the C# compiler takes that and just completely rewrites it for us so that it does something more complicated. And it works with default collections because they implement IEnumerable. Exactly. All of the built-in collection types in .NET implement IEnumerable. And any type that you make, that you implement IEnumerable, for each loops will work on that too. But by just in general, every collection in the BCL implements IEnumerable, which is why they work with for each loops. For each loops really aren't that magic. They're just a sort of marriage between a construct defined in the C# language specification and a type that's provided by the BCL.
Cool.
Okay, so yeah, are there any more questions? This stuff is fairly important, and it will play into what we're going to be discussing in 103 in a very big way.
Important kind of way.
But I kind of wanted to give people, because for each loops, before I knew how, I mean, I came to C# having worked with other languages, so I knew what they did. I mean, I knew how to use them, but I found it incredibly interesting when I actually dug deeper and found out what they do behind the scenes and how we can take advantage of that to write some amazing stuff. I do want to take one quick aside, though. One quick aside, because there really isn't that much time left in class today. The one quick aside is something that Unity 3D does, the Unity game engine. It's a very interesting abuse that I believe is warranted. I think the syntax is very concise for using IEnumerables. They're called coroutines. Basically, in Unity, you can do something like this. This is a very interesting and unique use of the for each of yield iterator blocks. If I have a coroutine, like a static void my coroutine, actually it can't be static void, it must be static IEnumerable. My coroutine. You can write code like do stuff to game object 1, yield return new wait for, I can't remember what the class is, but it's like wait for seconds 10. And then we say do stuff to game object 2, yield return new wait for frame, and then maybe we want to wait 20 frames. The point is that with Unity, the Unity game engine, they use the yield statements, and then when you yield return these special classes, they'll pause the execution of the method until these special classes indicate to Unity that the method should resume. So if you wanted to implement like a countdown in Unity, you would do something like this. You'd say for var I equals 0, I smaller than 5, I plus plus, and then you would say, you know, update text to, say, I seconds left, and then you would say yield return new wait for seconds. I can't remember that's the exact name of the class or not, but the point is that you would say yield return new wait for seconds 1, which will pause this method until 1 second has passed.
It's also quite handy for letting you very straightforward manner ensure that things aren't getting done too often.
Yeah.
Basically, you can give everything its own sort of unique fixed update in this way. By, you know, for instance, something like a pathfinding routine, which is very heavy to calculate, you wouldn't want to do on every single frame, perhaps. There's got to be better examples, but I can't think of any.
Well, yeah, it's great when you want to defer things based off time, and it works because the C# compiler chops this method up. But yeah, so that's how that works. Yeah, it'll wait for a few seconds and then resume this loop. So this will wait for 10 seconds and then resume the method. Then this will wait for 20 frames and then resume the method. This will enter a for loop, and every iteration of the for loop, it'll wait for 1 second. So it's very fun stuff. I think that understanding the yield statements is going to be important to actually using this within Unity. Otherwise, it could be very confusing. But again, it's just something fun. But it won't wait until it made it to the for loop. Yeah, once it enters the for loop, it'll start waiting again every iteration. Okay. So any more questions about yielding? So it'll wait to jump to the for loop after the first. Yeah, it'll wait. You have a bunch of code here. Pretend you have a bunch of code here. Then once it reaches line 14, it'll yield control back to the game engine and wait for 10 seconds. After 10 seconds, this method will resume and we'll do more stuff right here on line 16. And then line 17 will wait for 20 frames, and then after that we'll enter the for loop. And every iteration of the for loop will update text to say, 1 second left, 2 seconds left, 3 seconds left, and then that'll wait itself for a second. And that's just using the construct of a iterator block in C#.
Cool.
Wait, where's the for loop?
Line 19.
Well, line 19. I thought yield needed a for each. Not necessarily. A yield just creates an IEnumerable. You can do whatever you want with the IEnumerable returned. Unity is not going to place this in a for each loop. It's going to say, move next. And then it's going to say, what object got returned for me from moving next? Oh, I got to wait for a seconds object. Now I'm going to wait for 10 seconds. After 10 seconds, it'll be, okay, move next again. When move next again gets invoked, it'll say, ooh, we got to wait for frame 20 object. Let's wait 20 frames, and so on and so on. Okay, so, yeah, I guess wrapping up, there's a few terms that are important to understand that I will be making use of, especially once we start getting into C# 103. Those terms are things that people probably, again, have already gotten a concept for, a feeling for, but it's great to be able to give these names that would allow you to express yourself to other developers more easily. The first one is coupling. And there's going to be two types of coupling, implicit and explicit. Coupling is bad. Coupling makes things not work right. Now, you always need coupling at some level. If nothing in your program was coupled, then nothing would happen because there would be no relationship between the two, between different parts of your program. So you need some level of coupling. But what coupling is it's when one class depends on another class. And that's it. If one class depends on another class, then it's coupled. And that's an example of explicit coupling, when you've explicitly coupled the implementation of one class to the implementation of another class. What you should typically do instead, now remember, this isn't a principle. This is a metric. All of these things I'm going to be talking about are metrics, well, except for indirection. And when I say metric, I mean it's a thing that you have to measure while you write your code, and if the value of the metric gets too large, then that's an indication, a red flag, that things should change. So that's what the concept of coupling should be used for. And the idea of coupling is that you don't want your concrete implementations to depend on other concrete implementations. Because by explicitly coupling those two concepts, you have essentially created a situation where one change in one class can impact another class. Now again, this isn't a principle. Don't say, oh, well, I can never have two classes talk to each other. The fact is, sometimes coupling is necessary, is absolutely necessary. And we're going to be talking, there's another term that we're going to be talking about today called indirection that will be a pattern that we can apply to our code to represent coupling without having as many drawbacks. Okay, implicit coupling is even worse than explicit coupling. Implicit coupling is, I don't even know if this is a coined term, but I think, pretty sure I'm the one who invented this term in my own head. And when I say implicit coupling, I mean that there's two classes in your program, let's say, for example. There's two classes, and they both modify a tertiary class. They both modify a similar shared resource. And the success of one of those classes is implicitly predicated on the success of another class. So something like, let's say we have class 1 and class 2.
Oh, no, don't do that. Make it a concrete example of some sort, please.
I'm so out of names. I mean, what, you just want these unique names?
It's just so that there's some sort of context to it. You're naming classes, man. You can't call your classes class 1, class 2. That's disgraceful behavior.
Okay, fine. I'll say this class is...
Make it ponies if it makes you happy. I don't care.
Okay, fine.
Give it some sort of...
Okay, so the idea is that this top class has, like, let's say a method called, or let's say public string, public int current, no, that's a bad example. Public int, I don't know what I'm doing, age. These are terrible examples. And let's say both of these classes require an instance of the class that they're implicitly coupled with.
When I was saying give things, names, make it, I kind of meant one that made sense.
I can't think of an example that makes sense in this current. To keep it short, the problem with implicit coupling is that it happens to you when your program is very large and complex. And what I'm saying is, let's say this class does something like sets the age to 20, and this class prints out the age for some reason. What we've described here is a sort of implicit coupling where this class should be invoked, should be used before this class, even though neither of them have direct knowledge about each other. It creates a situation where you have to do this one thing before another thing. The funny thing about solving these problems is that these problems are solved by explicitly coupling them. You never want a situation where you do not express necessary coupling explicitly within code. Because as you see in this case, you have no indication reading any of these classes in isolation that they have any relationship to each other. But they do have a relationship to each other. And you have this sort of implied contract between the two that isn't expressed in code, which is bad. The way to properly work with this code is to explicitly define the relationships between your different classes in a mediator or a controller or another manager type class that would express that coupling. Because you don't want to couple them indirectly, implicitly. Otherwise, these will cause bugs that you cannot track down, because you'll be like, oh, I can just remove this class, nobody's using him, but wait a sec, I just destroyed a bunch of aspects of my program because he reached out and modified some external piece of state, and my other classes depended on that modification, and now when I removed that one class that did the modification, seemingly inert change, has caused my program to blow up. So does that sort of make sense? I can't... Are you muted, Gav? Or are you still here?
Mm-hmm. I assumed you were asking everyone.
Well, yeah, I was also asking you because you had a problem with my example, and I admit that is a terrible example, but I just wanted to make sure that I made myself clear in spite of that.
Yeah. If you managed to make it less clear than it would have been just using class 1, class 2. My point, Anyway.
Yeah, but the point is, you don't want multiple classes depending on state changes from other classes unless that dependency is represented in code. Okay, so let's talk about cohesion. Cohesion. That's how you... Cohesion, sorry.
There you go.
Yes.
Yeah, exactly. Segfault says, homage cannot work properly unless an implicit and non-existent contract is fulfilled. I'm going to talk about a controller-y type class once we talk about indirection, because indirection is sort of a pattern that we can use to make explicit coupling less bad and make implicit coupling non-existent. Okay, so cohesion, very close to the English definition of the word, surprisingly, because that seems to not be true of many things in programming, is about...
sticking things together.
Well, yeah, it's about how similar the members of a class are. So, for example, if I have a class, my class, and it has a public void write to database, and then a public void raise the sun, and then a public void feed the dog. This is an example of a class with low cohesion. Again, cohesion is a metric. It's not a principle. It's a metric that will allow you to identify if your class is potentially going to cause issues down the line as far as your design goes. Cohesion will typically go hand in hand with the violating SRP, because if your classes follow SRP, your classes will typically have high cohesion.
Well, see, now here's a point where actually your appalling naming and dodgy choices of things as examples works perfectly. Here's a question for everyone. What should this class be called? More clearly, on what basis would you sensibly name this class? Is it it's not a database writing class. It raises the sun. Yeah, exactly. Like Rollinson says, I do everything. It kind of defeats the point of being a class.
Yep. And it's example of very, very low cohesion and a very gross violation of SRP. Did I say something, or?
Segfault, that's genius. No, he said, no, it's not an interface. So, yeah, you're absolutely right. It should be do everything, not I do everything. Lovely. I do like that. Sorry.
Okay, so again, it's just a metric. When I say a class has low cohesion, I'm saying that the members within the class are not closely related to each other. When I say a class has high cohesion, I'm saying that the methods have lots to do with each other. I want to point out just a funny aside. Sometimes low cohesion is appropriate. Now, just like violating any metric on purpose, these instances should be very small and very controlled. But a particular commonplace example of low cohesion and high coupling exists within controller logic. Controller logic is something that actually goes right into the next topic of indirection. Indirection is the idea that two objects shouldn't necessarily know much about each other, if at all, but they can be combined to perform a specific result. The coupling is indirect. Now, it's not necessarily implicit coupling because you express the coupling in an explicit way, but the classes themselves are well designed. A controller class is a class that's responsible for mediating the relationships between multiple objects. Now, the design of a controller is less important than the design of the rest of the classes within your program. Controller methods should be very short. However, they can violate some of the principles of coding. Because typically what you'll have is your controller will be responsible for taking in different pieces of information, different pieces of user input, different pieces of a situation that might have arisen and the controller was notified of it. And it's responsible for taking in that external state change and turning that state change into a command that is sent into their system. Now, the system that you write should be well designed, and it should have low coupling, and it should have high cohesion. But the controller can get away with violating those metrics because it just defers to those other classes. And again, it should be typically very small. So if you go, on any MVC-based program, and you look at a 300, 400 line controller, and you'd be like, this breaks SRP. This has high coupling and low cohesion. And I would be like, yeah, but the fact is, each one of the methods is only like 2 lines long, and all it does is it defers to other bits of your code. The maintainability of the controller is increased by the fact that you should never do much within the controller. You should just tell other things what to do.
It's middle management, really.
Right.
It doesn't do anything productive itself. It just tells other things what to do in what order.
Yep, especially what order, too. A controller is where you will represent what would have previously been an implicit coupling. You'd represent that by saying, okay, you're doing this now, and now you're doing this. And that's represented in code. Meaning, if you were to delete that class that made some external state change that other things implicitly depended on, you get a compiler error because the controller itself is going to say, well, now this class doesn't exist anymore. Because you've actually represented that relationship in code, which is very important. So that's sort of the thing about indirection. Indirection is the idea that classes should talk to each other. Object-oriented design is all about the relationship between classes, but that relationship should be expressed in a very coherent, in an imperative, and in a readable and understandable language. And typically that's what a controller layer does.
Basically, you're making life, assuming that you have to make changes in the future, you're making it easier to make safe changes if you follow these things.
Yeah.
You're less likely to destroy half your program just because you have to change something from dealing with ints to floats or strings to characters or...
And also, typically, when you're using a framework like ASP.NET MVC or Fubu MVC, or even Rails, the controllers are typically how those frameworks plug into your code. Even in code that has nothing to do with web development that I write, my controllers are responsible for listening to the user input and what the server is saying should happen. And by listening to both of those things, it represents the interaction with the user and it represents the interaction with the server, and then simply delegates the other components. And that results in significantly less code because I can take advantage of things like interface implementation or naming conventions or reflection or generics to express what events that my controller might handle in a strongly typed manner that would otherwise be ugly if found anywhere else. Okay, so are there any questions about stuff or things? No?
It would seem there aren't.
Well, this is the last class, and it has been about another hour, so I think I'm going to go ahead and pause the video, step outside, and wait for any questions to come in. I encourage anybody to ask questions, because this is it. We're not going to see you guys until
For a couple of weeks.
few weeks from now. So, all right, we are back. So yeah, so let's go ahead and pull up a quick whiteboard about yield. Just really quickly, I would encourage people who are having problems with yield to type it out and work on some examples, maybe replicate some of the examples we had earlier in the class. But I'll try to diagram out really quickly kind of what's going on with it. So let's say we have a iterator block. So an iterator block always returns an IEnumerable. And let's say we're returning an IEnumerable event. And let's call this method get. That's too far away. Aw, Segfault's leaving.
Go to bed, Seggy.
Well, you know, it is 10 past 5.
I know. Good night, Segfault.
Wick, I think it's Coptic.
All right, can everybody read what I have just scribbled on the screen? Besides done.
For each var num in
Get int. Console right line num.
Console.writeLine num. IEnumerable int get int yield return 5 and 10.
Yep. Okay, when get int, when this method is invoked, it returns an IEnumerable of int. However, the object that it returns is an instantiation of a class that is generated for us by the C# compiler. However, for each invokes the moveNext method. When for each invokes the moveNext method first, this happens. Yield return 5. This value of 5 is placed inside of the num variable. This 5 is placed inside of the num variable, and then execution continues on the for each loop. Execution terminates right here in getInt. This method is paused. The 5 value goes into num, and the for each loop continues. However, once the for each loop reaches the end of the block and iterates again, what's going to happen is execution will resume on the next line. And execution will continue in this method until another yield return statement is found, which it does right here. The next line is another yield return, although it didn't have to be. And it'll return a 10. The 10 will be placed into num again. And then the for each loop will execute one more time. At this point, execution is paused right here. This method, although it doesn't have any more code in it, is still paused. It's going to continue to be paused until the next moveNext method is invoked. The moveNext method is invoked when the for each loop ends its block right here and jumps all the way back into the for each loop. Then the for each loop will invoke the moveNext method again, which will return false. The moveNext method will return false because the iterator block is over with. Is there anything more specific about the yield return statement that's confusing? The yield return statement, all an iterator block is about pausing a method and yielding back a value into the for each loop that invoked it. Yeah, it's letting it return more than one thing, essentially. It's returning, well, it is returning one thing. It's returning an IEnumerable event, but that one thing it's returning, an IEnumerable event, think about it like it being filled with the individual items that were yield returned. So the individual items that were yield returned get coalesced into the IEnumerable that gets sent back by invoking this method.
With a normal method, you've just got a return statement. You had something that return, int return type get in that just returns 5, and that's like it's like, because you said it's like pausing. That would be like stopping a CD. You stop the CD. Next time you call the method, start at the beginning again. It's like playing the CD. With yield return, it's just like pausing a CD. The next time you come back to that method, you unpause it and carry on from where you left off until you get to the next yield return.
Yep, and then it'll populate the variable you have defined in your for each loop with whatever was yield returned. So IEnumerable of int can be thought of as a collection of yield statements. Each time move next is called, you get the next yield in the block. Very, very close, but actually the other way around. A collection of yield statements is an IEnumerable event. But as we saw earlier, there are many ways to implement IEnumerable event. There's many ways to do that. Yield is just one way to do that. But you're correct in saying that your IEnumerable, when implemented in terms of a yield, is going to feed back the things you yield returned, and then pause the method until the next thing is asked for. But does it need a for each? 99.9% of the time, you will use the for each statement to work with IEnumerables. That isn't always the case. For each loops are just syntactic sugar over using a IEnumerable to gather items out of a sequence. That doesn't mean that it is impossible for you to invoke the methods or the method of an IEnumerable manually if you wanted to. You're more than welcome to implement or to invoke that code manually. But you typically won't, because the for each loop's express purpose is to provide a wrapper around using an IEnumerable. Well, it works without a for each loop, just like what we saw before, where...
Take for example, you could essentially use that to create behavior whereby the first time you use a weapon, or the first, different behavior depending on how many times you've used it.
This is how you would use an IEnumerable directly. We've gone over this quite a few times here, where this is what a for each loop is expanded to. You would not ever typically do this unless you have a very, very advanced scenario. But you can. The for each loop is not magic. All it is it's a language construct that takes this code and transforms it into this code. It's nothing more than syntactic sugar that causes the C# compiler to generate additional code for you. Yeah, you're going to need to use one or the other. You're going to need to use a for each loop, or if you have a more advanced scenario, you're going to have to get the enumerator manually and invoke the move next method manually. That's how I implemented the skip method. I grabbed the enumerator directly out of the enumerable and worked with it manually, because I couldn't express this logic using a for each loop very concisely. So there's two ways to work with an enumerable: a for each loop, or grabbing directly into its enumerator.
But like Nelson says, 99% of the time you're going to be using a for each loop, just because by its very nature a for each loop exists in order to iterate over things a specified number of times.
Right.
Which is for which purpose the enumerator is perfectly designed. They kind of go hand in hand, but aren't. But, it's not a given. You don't have to. There's nothing that says you have to use a for each, but it's the thing that's specifically designed to be used for it. In exactly the same way as you could, if you had to paint a room in your house, you could use the same brush that you would use for painting lead miniature models. But it would take you an extraordinarily long time, and you'd be far better off using a roller. You can access the yield. You make use of yield returns in a manual fashion, but if most of the time you're going to find you'll end up doing a for each longhand. Does that make any sense?
Is for each quicker than using a standard for loop? Really depends on what you're doing. Mm-hmm. They're not the same construct. You typically will use a for loop to loop over a range of values, and you'll typically use a for each loop to loop over a sequence of values. And if you can get away with using a for loop, it's probably quicker by an order of hundreds of billions of nanoseconds, because there are fewer method invocations involved, but the readability that you would lose would not be worth any amount of the performance you might gain from doing so.
See, I've always, you can just say well, this is a good or a bad idea, but I've always tended to use a for each unless I actually want to use the index in some way as part of whatever I'm doing inside it.
Yeah.
In which case I use a for, and because obviously if I'm going to be using the index, there's no point in doing a for each number in take and skip FizzBuzz. First thing you do, work out the index of the number. There's no point in doing that.
Well, yeah,
But otherwise, I'll use a for each loop.
Yeah, and typically I will too. The only problem with that, though, is that you can't index IEnumerables, and since I always expose my collections as IEnumerables, I'm typically put in a situation where using a for loop is impossible.
Right.
But if you're using an array or a list, then using a for loop, if you need the index, would probably just be cleaner code. Like it's not a matter of performance; it's a matter of what it looks like.
It's also probably worth noting that although this is, I would say, an intermediate level thing, the more advanced concepts we start to deal with, they are going to be things where not only do they tend to be applicable generally to more sort of specific groups of problems, but also there are going to be more and more situations where there's multiple ways of doing things, and it's a question of suitability as much as what you're forced to do.
Yeah, as the complexity of a problem increases, the amount of potential solutions increases, and it becomes a game of trade-offs at a certain level, and it becomes a game of trade-offs of looking as far as you can into the future to anticipate problems with your design, and as well as the existing baggage of how you've solved problems in the past. Complex problems do not have They do often have simple solutions, but the solutions that you architect are going to be very different between programmer to programmer. Okay, so what about the yield? You had waited for a few seconds and then did the next line. How's that fit in? That was an example of Unity.
That was in Unity, wasn't it?
Yeah. I don't even have that example up anymore, I don't think. That was an example of a feature in Unity itself, the Unity game engine. It's not a feature that's built into the C# language. It's just something that Unity does that uses the exact construct that we've been talking about today. But it's not going to magically work for you unless you wrote the code that would have been implemented into Unity to get it to work.
So
yeah.
I guess that's very new. That must be pretty much about it. I've amended the homework thread.
Yep. The homework will be the same as last week due to a variety of things, one of which there were a few entries, and it would be great to see people and to give people the time that they need in order to follow through with it, because I personally really like this homework, and I think that it will give people the personal experience of being able to use the things that we've talked about in regards to design to sort of identify maybe some mistakes that they made in their own code base. Because when it comes down to it, identifying the mistakes you've made in your code base as far as design is the quickest track to acquiring a sense of design. We can talk about it all day, but unless you apply it and keep what we've talked about in mind, there's really not going to be a whole lot of progress.
And also, it's one of those frustrating things with programming, whereby by the time you finish programming something, you'll have learned so much in the process of programming it that you'll look at it and go, well, I need to redo that.
Yep.
It really is. It's on the way up, it's quite a lot. Yeah, words.
All right.
My brain's just like gone, no, enough words.
Yeah, I know. The sun's already up there.
You do know I've done more speaking out loud during these classes than I've done in probably the last 5 years. So it's just I've run out of words. It doesn't work anymore.
Well, it's pretty early in the morning there. No, Nelson, I think you've done an excellent job going over this stuff and over this stuff. It's just a matter of getting this video encoded and put up along with last week's so that those that want to go back and review it again and follow along and make use of the pause button can do that.
All right. So I'm going to go ahead and stop the video, and to all the future audience, goodbye.
Goodbye.
Bye.